Hello and welcome to another tutorial. This time round we are looking at the final part for the character controller series. So up until now we've gotten the bits going for being able to move, being able to look around, interacting with World Space UI. We got stairs, jumping and falling, and some changes there happening with things like physics materials. So we've got a lot of those things now up and running. What we want to focus on now today to start off with is getting things like audio and that going. So what I've already done, if we take a look at the project, is I've brought in a number of audio files. These are all Creative Commons 0 ones. I've chucked in the credits here, so if you're looking for the original sounds, you'll be able to find the original sounds there. So they're all from Freesound. So that's ones where if you're looking for stuff like those particular sounds, you'll be able to grab them from there. So in terms of with the audio, what I want to set up for this is I'll set up stuff for triggering like of a footstep event and for triggering like of a landing event. And if we take a look, we've already got stuff for like a hit ground event and things like of that. So the reason I want to set this up as events is because you might be working with different audio systems. Because you could be working with the built-in stuff in Unity, you could be working with an audio engine like Fmod or Wwise. So setting it up using events means that it's very easy for you to then plug in your own audio system, or there might be other things you want to have happen when stuff like a footstep sound needs to kick off. So to start off with, we are going to start working on our character motor. And we want to start getting each of these events happening is going to be the first thing. So we've already got our on run changed. We've got our on hit ground. We'll have on jump, and that will be a new Unity event. And we'll also have a Unity event for on footstep. And what I might do with these is, it is possible we might want to need to provide something like the location. So I'm going to actually change all of these so that the location gets passed through. And that way then if our receiving bit of code needs to know the location, then it can easily work with that. So, okay, that's good. We've got a couple of those ones there. So there's a few things then we need to set up. So one of the things we're going to need to update is our on-hit ground. So we'll invoke that and provide the linked rigid body position. So that's going to work for when we've hit the ground. We also need to then kick off the one for when we have started a jump. So we're going to have here, so if a jump is being triggered, then after we've done all of the general logic there for it, we will have on jump invoke linked rigid body position. And then the final thing we need to do is start getting stuff set up for the footsteps. So with the footstep sounds, we want to play them only when we're obviously on the ground. So that's something where what I will do is we could do that here. And this is probably a good spot because if we're not jumping, then that's reasonable for doing the footstep sounds at that point. So I'm going to have update footstep audio because there's a little bit of logic that we want to use for this, because we think about it with the footsteps, the speed of them should change as we are actually moving sort of faster. So we want to have these be working fairly well. So have our update footstep audio. So that's going to need to do not too much, like it's reasonably simple logic. But what we can actually do is we can be looking at the distance that we're moving is one option there. So with updating the footstep audio, we know stuff like of our previous location. We could be checking how far we've actually moved since the last footstep. So I'm going to set these up here. Distance moved since last footstep, which will be 0. We're going to need to keep track of our previous location. So previous location, which that's something where at the very beginning, I'm going to make sure this is properly set up. So in our start function, previous location, link rigid body position, just so we've got that properly up to date from the very beginning. Once we have that, so that should be fine. Our on jump set up there, it's been created. It's likely just getting grumpy because of some other errors, but we'll come back and sort that in a minute if we need to. So then what we want to do is, for the previous location, we want to check, okay, well, how far did we move? So distance moved since last footstep. We take our previous location and we can just get the vector 3 distance, previous location, and our current position. So that'll get that distance. We can then also update the previous location. So we determine how far we've moved. So in terms of the footstep interval, that should be different depending upon whether we are walking or running. So in our character motor config, so if I open up the config, we'll have audio, header, audio, public float, footstep interval, walking. So with walking, these will be a little bit of a guess. I think if we say, if we're walking, the interval is something like 0.5, maybe 0.4. And public float, footstep interval, running, might make that 0.2. So what we can then check here is, okay, well, if distance moved is greater than the footstep interval, which we can store that. So footstep interval, if we are running, then we use the running one, otherwise we use walking. So if it's greater than or equal to the footstep interval, then on footstep, invoke linked rigid body dot position, time for footstep audio. So we invoke that, and then we just need to remove that interval from it. So what I would be able to then do is distance moved since last footstep, and we just subtract it. Now I'm going to move these up to the top. So these are just general ones that we want to be tracking. The other thing that I'm going to do is, as soon as we return to being on the ground, so if that's the case, I'm going to drop that to 0, because that makes sense. We've landed back on the ground. We should use a different result there. We shouldn't go and immediately be playing it. So that's looking pretty good. We just want to check with the grounded So we were updating it there. We've already got a bunch of other things that are checking the is grounded. So for consistency, I am actually going to change that check to there. So that's looking all right. So it already has, okay. So that's why it's causing that to happen. So on begin jump is what we'll call it. That will avoid it being any collisions there. So, okay, we've got our events that will now fire off for those different things. So that's good. So what I will do is I will set up Footstep audio built in. And so this will just be the default one that we actually use. So this one, I'm going to set up serialize field, list of audio clips, launch sounds, serialize field, another list of audio clips for, well, actually that'll be begin jump sounds, we'll call that. So begin jump. We'll then have hit ground sounds, and then finally our list of ones for footstep sounds. So that will be good. I might also with the footstep one, because I could see this being useful, pass through the speed. So make sure we pass through the speed as part of that as well. So I could just see that being really useful, in particular if you're working with an audio engine. That could be something where would be really quite handy. Just pass through the rigid body's magnitude. So the reason that could be handy is you might be doing additional effects, things like of that being dynamically driven by the speed. So that will work quite nicely. So set also up a serialized field for an audio source. Linked source. We are going to require component audio source. Actually, no, I won't require it because we could be playing it on anything, so I won't require that. We'll have then on begin jump, which takes in a vector 3. And then what that's going to do is linked source play one shot, and we'll pick begin jump sounds dot, and also we pick a random range like that. So that will work for begin jump. It's going to be pretty much identical for all of these, because they're doing the exact same thing. So hit ground sounds will be the next one. So on hit ground, and then the final one will be the footstep sounds. Float. Current velocity. So on footstep. So that's good. So this gives us then something that we can just attach onto it that will be handling the playing of the audio. So I'm going to create an empty object. Sound emitter. And I want to just make sure that is positioned at the base there. Going to add in an audio source. Turn off play and awake. Not that we're going to be linking something up anyway directly, but just good to have it there. We have our footstep audio. I can link up my audio sounds for this, which I'm just going to bring the audio under the character motor folder. So we'll have our landing, have our launching sounds, and we'll have our multiple footstep sounds. So there we go. All of those are linked up. Then our player, well, our player is going to need these different events connected up. So begin jump, hit all of these. We link them up to the sound emitter. And then we should have a dynamic function here. So we have the on hit ground, then we have our begin jump, and then finally our on footstep. So that should give us audio. Now we might need to tweak the settings for the intervals there for them, but that should give us some functioning audio. Okay, so we can now test this. So let's see. We likely need to adjust some of the settings a bit. So it is very, very frequent, and it is a little bit on the loud side. So the volume there, I'm going to drop that to 0.8. So it's happening less frequently. Well, so it's not quite as loud. It's still pretty loud. I think if I drop that from further, that's better. And I would say further again, it's probably going to be better. So, because the sounds are quite loud, but they're also super frequent. So the interval there is really, really close. So we do just want to double check with this in terms of when we're running the footstep sounds, of just keeping track, make sure that we are properly keeping track of the previous location, which we are doing that correctly. It does build up. The intervals are being checked correctly. So the logic checks out, but it's happening quite frequently. So if we go to our config, the intervals here, we're going to adjust these. So I'm going to change the walking one to 2.5. This is going to be down to the character speed. So at the moment, it's going to be a little sensitive to the character speed. So that feels about right. Now, if I run, it's obviously just an absolute cacophony. So probably the running, if I drop that to 1, so even at 1, that's still quite large. So maybe if I go for 3 and 1.5, so it is a bit of balancing that you need to do with this. So the running still definitely, I think the running can probably go to 2. So the difference between these is not that much, and it doesn't, distance isn't really giving us a great sort of control. So I'm going to actually change these. Distance is something that should work better than it does, but unfortunately it doesn't tend to work so well. So what we're going to do is this is going to change to time since last footstep audio, and we will add to that time.delta time. So update time since last audio, because this way we get control that will be independent of the speed. So if the time is greater than that, then what we can do is that subtraction should work fine. What we can also then do is we don't need to be keeping track of that previous location. So we can get rid of the previous location there. We're not really using it. So this will mean then our settings here, we can probably go back to my previous ones. And this will just have a little bit more control, and it'll mean if you change the speed of the character, it'll still be okay. But we also, time is part of what we need to check. We also need to actually check that we've been moving. So F, and we want to look specifically for input movement and that magnitude being greater than our float epsilon. So being above just a very small value so that we know we've got some input. So is the player attempting to move? That should just give us a little bit more predictability and control to it. That feels better. And same with running, so that's good. Now what about falling from something? So we're not getting that one for having hit the ground. So what I want to do is we'll capture when we are in the air, and we'll need to restart. But we'll capture that moment of being in the air, and then we'll capture when we fall back down. So we've be falling now. So then we'll check for when we have then now returned to being up in, or no longer being grounded. So here I want to place a breakpoint for that changing. So that should mean the on hit ground is going to fire. Then I want to check grounded being set to true. So grounded's been set to true. So let's return the hit result. And the problem is we were checking the was grounded too late. So these both go moved up to here because they need to be checked earlier. So easy one to miss, wasn't causing problems for other things, but in this case was something that was then causing those sounds not to fire. So that should mean I jump. So that works. That's good. So we can jump, we get our fall sounds, we get our step sounds, and if we sprint, then we get much faster sprint sounds. So that's good. So we have our setup going for the audio kicking off, which is great. So a couple of other little things we want to make sure that we have just to make this as usable as possible. So our set cursor lock is already there. So that's a really handy one to make sure that we've got. The other thing that can be really handy is being able to freeze either movement or rotation. So I'm going to set up void set movement lock or locked, and a similar thing for a set look lock. And what I'm going to do is we'll have public bool is movement locked, which will be the usual ones, and a similar thing for is looking locked. And then we can just update these here. So what this will allow us to do, so if movement is locked, that gets updated. If looking is locked, we update that as well. These will just allow us to, then we can go and check these and make sure that they're doing, that we're not applying things when we shouldn't be. So the looking is a reasonably easy one. We, in our camera function, F is looking locked, return. Not allowed to look around. Now, movement is a more interesting one because this comes down to what we want to have happen when the character is, when we bring up like a menu or something that locks the character like of that. Are we wanting to lock physics as well at that point? Depends a lot on what we're wanting to actually be doing. At a minimum, we want to make sure that we have no input. So this would be something where what we would do is F is movement locked. And that somehow got a very different name to what it was supposed to. So we'll just update that to is movement locked. So what we want to do is F is movement locked. Then our input for the movement comes a vector2, 0. Movement locked. So that'll allow us to turn off those settings. It's grumpy because that shouldn't actually be grumpy because the thing can be connected. I will make it protected just for consistency, but that is not something it should be getting cranky about because we are using the linked camera. So that seems a incorrect error. All right, so we've got debug controls already for stuff like override movement and that. We could easily set up some stuff to have it that it can send through those commands of changing that state. What I could also do here is serialize field, detect a bool, debug, toggle look lock. And another one for a protected bool, debug, toggle movement lock. And then what we do down here is in update, F, debug, toggle the one for looking. First thing we do is we set that to false. So then is looking locked gets set to the not of that. We do the same thing then for movement. So debug, toggle movement. So is movement locked? So it just allows us to easily test these. This can be really handy for if you bring up menus, you don't want stuff like of that where the player is moving around. So we can select this. And at the moment I can look around, I can move, all of that's working. If I come here and I'm going to turn off looking, then I can't look around. If I toggle that again, then I'm able to once again look around. If I toggle movement, then it's ignoring all movement inputs, and I can toggle that again. So that's good. We've got movement toggles, things like of that happening. So I'm again going to update that prefab because we've got all of the key bits going there. So that's good. We've got our sound emitters. We've got the ability to be toggling on and off movement, and we can do that independently, which is great. The final thing I want to add in is because we do have a thing here for the run changing, but we don't have anything currently where we're doing something like a FOV kick. So that's something where I'm going to set that up as an extra little bit. FOV kick. And what this will be is we'll set this on the player camera. And I'm going to close those ones because they're not ones we're needing. I'm going to set up just some subfolders here for stuff like the audio, for stuff like camera effects, which is what the FOV kick is a camera effect. So camera effect can go into there, and we'll also have one for the UI. So this is debug UI. And I'll actually, that can stay, I'll move that folder out because it's not really part of the character controller. So there we go. With the camera effect, we have already attached that onto here. So we can see the setting for controlling the FOV, and we can see what happens when we change that. So what we would be needing to do settings-wise is float walking FOV, which we'll set to 40. And then we'll have a running FOV, which I think something, we'll try going to like a 50 and see how that feels. We'll have a FOV slew rate, so how quickly it changes from one field of view to another. So that's something where if we set that to 1, it would take it 10 seconds, which is way too slow. We want this to be something where it's like that, so it needs to be really quite fast. So I think slew rate wise, something like probably, I feel like maybe we're talking 20 even feels too slow. I feel like something probably like 50. So I'll have target FOV, which target FOV is going to be equal to our walking FOV. Now we are going to need to be able to access our Cinemachine virtual camera. So we're going to need to bring in Cinemachine. That will allow us to then have a Cinemachine virtual camera, linked camera, because then what I'm going to do is check if target FOV is not equal to our linked camera, and then we have to find the area that it is under that. It's likely going to be, I think, under lens and then field of view. There we go. So if the target FOV is not equal to that, then linked camera, lens, field of view, we do a mathf move towards. We are moving from this current field of view to our target field of view. So target FOV, and the amount we move is going to be our FOV slew rate by time.delta time. So update the FOV. Then we'll have a function here, void, and we can see what that interface looks like for it. So we've got our event for run changed. So on run state changed, bool is running. So then target FOV is equal to, if we are running, then we use running, otherwise we use walking. So what this should mean is we do get that FOV kick happening, and we've got it isolated in a separate file, so it does mean that it's something where if we wanted to swap in different ways of doing it, then we would easily be able to do that. So we've got the linked camera, so that means again on the player I can link up this event, goes to the camera, FOV kick, and we have the dynamic one. So I'm just going to have the play one selected so I can actually be watching and see, like if the field of view, if that changes. So we're walking along, going to start running. So it does change, hasn't gone and changed back, so that's something where we're going to need to sort out that. The amount of change, it happens pretty rapidly and maybe actually too rapidly. So I'm going to change the FOV amount there that it changes by to 60, and I'm going to drop that to 10 because it was pretty rapid that it changed. And we just want to check where we're using this. So this should be happening as part of that. I want to check that there's not anywhere else where we are updating is running. So we do have stuff for if there's no input. So that's one that would be changing it. So we likely want to move that around. And that's the only place outside of the update running that it's changing. So what we'll actually do is we will move this check to here, because that way we can actually have this all properly update. So that should work. I want to just check with the camera, because I am updating the Cinemachine one, but I want to make sure the camera here does actually change field of view as well. I want to make sure it is properly feeding that through, that there's not something going wrong there. So we're running. So the field of view, we can see it did indicate that it's changed, and it does sort of move back there. I think we can probably go to a larger sort of change there. So I think we can probably go for a heftier FOV kick. I'm going to bring that slew rate back up again, and I'm going to actually chuck that field of view up to 70. So make it that it's really sort of stretching it out. So that is a lot more noticeable, and that transition is a lot quicker. I reckon that transition actually should be a little bit faster again. So if I go to 60, it would then be completing that transition in half a second. I think more like a third of a second. So what we could do is we could actually change that. So we set the time and it's doing it by a little bit of maths, but we could be using a slew rate means it handles it if you start like changing mid while the change is happening. So what I'm going to do is say I want 30 divided by 90. Let's go for, no, I want to get 0.33. So I think, yeah, 90 should be a bit faster. Should mean it takes about a third of a second for the change. And that's pretty quick. That feels good. I like how that changes. We could also try seeing, how it looks for changing the FOV the other way. Now 10 would be a little extreme, but let's take a look and see how that feels. A little bit weird. So we could probably try maybe going to 30 with a slew rate of 30. So it's dropping by 10. So it's down to seeing what feels sort of better, because it's going to change the perception of how fast it feels. Because that sort of brings us with it lower, and we can see just when we're testing here, lower brings us further forward, whereas larger spreads it out. And I think, just for my taste, I think going larger works better in that it actually pulls in more information for us. So we are seeing sort of a different amount there. I feel like that feels a little bit better, but down to sort of what you would prefer for how you want that FOV kick to work. So we've now got our fully functional controller. We can interact with buttons in the world. We can walk up and down slopes up to various limits. But we have ones where there are ones that are too high, we can't walk up those. We can, it prevents us moving into objects, which is good. We can jump. We're quick enough, we can double jump. We're able to walk over onto stuff like stairs. Now, the stairs one, noticing we do get our hit ground sound, and that is going to be what we likely would find is we have brief moments where we have toggled and then it triggers that. So for the hit ground, we're going to actually make it that there needs to be a minimum amount of time in the air for that sound to actually activate. So min air time for landed sound. So say we have to have been in the air for at least probably 0.2. Might need to tweak that, but 0.2 is probably about right. Just enough that it's sort of keeping track of that. So what we'll have is a protected float time in air is 0. So with this, we only do this if time in air is greater than or equal to config dot min time in air for the landed sound. So that's good. As long as we are on the ground, we do not want to be updating that time in the air. So what we also then want to do is time in air is equal to, well, if we are grounded, then it's 0. Otherwise, it's time in air plus time.delta time. So track how long we have been in the air. So that's just going to allow us to avoid having the stairs be quite so noisy, because they would otherwise be, as we found, really, really horrendously noisy, and we don't want that. So this, we might need to reduce this time a little bit because we still want to get the sound when we jump, but we don't want to get it when we are going upstairs. So I still get the landed sound there. If I fall off, I still get the landed sound. Let's try going upstairs. So I can jump onto them, I get the sound, but walking up them, I don't. And then let's just confirm with, if I then go for walking down them, I'm also not getting the sound, which is good. That's what we want. We shouldn't be getting the sounds at those points. We don't want heaps of that audio playing, otherwise it just ends up a really loud mess. So we've now got a fully functional character controller, so dive on in, experiment with it, throw it into other projects, see the kinds of things that you can be doing there with it. It's likely going to be something that I revisit later and add in further features to. So if there's things that you can think of that you'd love to sort of see added to it, feel free to chuck in a comment below. Always keen to have ideas of other things that folks are interested in seeing, and then look at being able to incorporate those is always great to be able to do. Thanks folks, I hope you found the video helpful and enjoyable. If you have, chuck in a like and subscribe, really helps out, really appreciated. If you're looking for the code for the project, that code is available up on GitHub, and I've placed the link for that in the description below. The code, you can use that in any of your own projects, commercial, non-commercial. The audio I used in this is Creative Commons 0, and in the audio folder there, you can find the links to the original source audio. So if you're wanting to grab those original files and work with those, you can get them from there as well. If you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link for that in the description below as well. But until next time, bye.